Hello, I'm Preethi Doss and I welcome you to my session. During my private delivery, I came across a customer story that was unique and interesting in nature. So I thought of running a small POC around the solution and I would like to share that with you. So the case study is containerized Azure function in AKS. So it is possible to package Azure functions inside a Docker container, which gives you the flexibility to run it on-prem, Azure cloud, outside of Azure, which is other cloud providers, and of course, wherever you can run Kubernetes. While it's great that this option opens the door to run Azure function anywhere, until recently, there was one notable drawback using containerized Azure function app. And that was the fact that the powerful autoscaling features of Azure Function Consumption Plan is not available. It would be up to you to scale out the appropriate number of containers. So let's look at how KEDA can solve the problem. KEDA is Kubernetes based event driven autoscale component. It is designed to solve this very problem. With KEDA installed on Kubernetes, you can benefit from auto scaling so that additional pods will be created as needed when your function is under heavy load, and it can scale right down to zero if your app is idle. It does this by exposing custom metrics to Kubernetes autoscaler, which is the horizontal pod autoscaler. So we can assume that using functions containers with KEDA makes it possible to replicate serverless function capabilities in any Kubernetes cluster. So let me talk a little bit about the solution. So we have a function app and it's based on a HTTP trigger. And extract out the request parameter and send that as an output to Cosmos database. Basically, we are creating Cosmos database as an output binding for this function app. And we're going to encapsulate all this, basically, make this into a containerized function and deploy this onto Kubernetes AKS. And we'll look at how KEDA comes into picture for auto scaling. I have created a KEDA demo app project, so which has a KEDA function. And as I mentioned, it has an input that is HTTP trigger, and Cosmos DB is the output binding. If you want to see a bit closer, we have the Cosmos DB at the output binding level. We key in or provide the database name, collection name, followed by the Cosmos DB connection string. And we basically extract out the request parameter and pass that request parameter as an output to Cosmos database document. And add async would pretty much do that. I have created the KEDA function app using function code tools. See, the advantage of that is a Docker file is created automatically. So the command is function init followed by the function app name followed by Docker, and I have the Docker file. Please do remember to place the connection string and Azure function app based file storage connection string inside the Docker file as well, so that it will be available within the YAML template, that is the deployment.yaml file, which will be used for AKS deployment. So the connection strings are also placed in local settings JSON. Next step, to build the image, let me give in the Docker command, Docker build, followed by the image name. So currently the image is created in my local. I already have an Azure container registry. Once the image is created in local, then I will push the image to Azure container registry as well. So before that, let's quickly test out the function. I'll expose the container. Providing the image details. Now my container is up and running. So let me copy the URL. So to this KEDA function, I can pass the request parameter. So description is something like my name. So this function is triggered successfully. To validate that, I can go to my Cosmos database. And browse into the Explorer. To do items, and within the item, I can see that there is an entry. There is a second entry, Preethi Doss, which is something that I passed right now. So my function app is working well. Next step, to push the Docker image into ACR. So let me log in into ACR. My Azure container registry name is ACR for KEDA. Let me copy the password. Perfect. So the Docker tag followed by the image name that is in my local, followed by the ACR image, right? So this will create the ACR image, and the next step is to push this ACR image. So while this is running, let's prepare to create Azure container deployment using AKS. So the image is now pushed to ACR, and inside my ACR, I can see the KEDA image v1 available within the repository. Next steps, to create AKS. It's going to take a bit of time. While this comes, let's prepare for AKS deployment YAML manifest file. Function Core tool provides you an easy way to create the deploy.yaml file. So the way that you can do is to call the function Kubernetes deploy, giving the deployment name and the image name. So the image that we had created and pushed into ACR, we're basically referring to that image, followed by a dry run. The dry run command would create the deploy YAML file for you, ready-made. So that makes your life easier while AKS deployment for containers. Let's go back and check status on cluster creation. So my AKS cluster is created. Let's do some plumbing activity to have the credentials registered. Now with this I can use my kubectl commands. So before going to AKS deployment for containers, I want to do a small activity which is to attach AKS with ACR so that behind the scene Azure will take care of the plumbing activity of having the right ACR pull RBAC for the AKS to pull the image from, right? So let's have that done. So as you can see, the role propagation is getting completed. Now this is done. Let's just check kubectl commands kubectl get nodes. So I have 2 nodes attached to AKS cluster, which is up and running. Now let's go ahead and install KEDA for function autoscaling. So KEDA namespace, install KEDA with the KEDA namespace will automatically install KEDA to the Kubernetes cluster. Now, as I told you, let's do the deployment, which is this command. It will automatically create the YAML template. Perfect. As you can see here, the deploy YAML template is available with all the relevant information. It has brought in the connection strings that is required. These are the secrets, like the environment variables that needs to be passed on for the container. And you have the KEDA deployment, the HTTP deployment for the function app. Perfect. So for the container spec, looks good. We have one replica set because KEDA will take care of auto scaling for the function app. So the deployment template contains information about container, which is the KEDA deployment HTTP, the trigger function, which is mapped to KEDA image v1 that we created and pushed into ACR. Next steps to deploy the template. So the simple command kubectl apply. So we have the service created. It's the load balancing service, followed by the deployment of the function app container, and it's exposed at port 80. To get the external IP address detail, let's place kubectl command to get the service details. So you can see the KEDA deployment is successful. Load balancer external IP address is available. Let's go ahead and give it a shot, accessing the same. So I'm going to key in the IP address, the external IP, followed by the API function name and the input parameter, which is description. Now this is the to-do list, right? So let me give something like grocery shopping or just shopping spree. Now this function app is successfully executed. Let's go and do a final round of test in Cosmos database because that output is bounded to Cosmos DB. I can go to Data Explorer. And within the items, I can see few more entries. Shopping spree is updated. Finally, I can test this deployment status by a kubectl command, which is kubectl get deployments. So the KEDA deployment HTTP function app is up and running. So with this, we could automatically scale out and achieve the serverless capabilities of function app on AKS using KEDA. I hope this demonstration was useful to you. I will see you in another one. Thank you.